A z-score, also known as a standard score, is a statistical measurement that indicates how many standard deviations a particular data point is away from a distribution's mean average. It is useful to standardize the data point values of a normal distribution by converting them into z-scores because it enables us to compare scores from different samples, which may have different means and standard deviations. So, by using z-scores, we can compare scores from different tests or groups and understand how well someone did compared to others. It helps us see if a score is outstanding or just about average. Imagine you have a group of students who took a test, and you want to know how well each student did compared to students from different schools. The z-score helps you understand if a student's score is better or worse than the average in a population. To calculate the z-score formula, you need three things. X represents the value you want to analyze, which is the student's test score. Mu represents the average score of all the classes in a population. Sigma represents the population's standard deviation, which tells you how spread out the scores are across different sample distributions. When you calculate the z-score, you subtract the population mean from the value you want to analyze, and then divide that by the population's standard deviation. The result gives you a standardized score. When the population mean and standard deviation are unknown, the standard score may be calculated using the sample mean, x, and sample standard deviation, s, as estimates of the population values. The z-score standardizes data by converting it to a common scale. This allows for easier comparison and analysis of variables that may have different units or measurement scales. It helps to remove the effects of different scales and focuses on the relative position of each data point within a distribution. If a z-score is equal to 0, it is on the mean. A positive z-score means that a data point is above a distribution's mean average, while a negative z-score means that the data point is below the mean. For example, if a z-score is equal to -2, it is 2 standard deviations below the mean. If a z-score equals 1, it is 1 standard deviation above the mean. Z-scores also allow researchers to calculate the probability of a score occurring within a standard normal distribution. Around 68% of values are within 1 standard deviation of the mean. Around 95% of values are within 2 standard deviations of the mean. Around 99.7% of values are within 3 standard deviations of the mean. Researchers use z-scores to improve rigor, objectivity, and clarity in their work, leading to a better understanding and knowledge of psychology.